And now let's get into the meat of this. Oh, actually, let me ask
But before we do, I want to comment on this kid. I mean, I put together the graphics for this thing. The whole graphics thing took just a few minutes, but I actually sweated to find that kid. Isn't he perfect for exciting clean tech business plans?
He makes me smile, I'll tell you that.
Yeah, for sure.
Okay. Yeah, so by the way, on this, is Renewable Still Doable? So this is your book coming out in January, and I know you've wrestled with the title here, so are you pretty comfortable with this title now?
I'm comfortable with it. I may, if I change anything, it'll be one word. I might go to, is renewable really doable? It still implies that there have been changes with respect to world appetite for this, which is true, but I'm not sure it's a point I want to make in the title. So whatever. These people at the publishing house are going to kill me if I make another change in this thing, but they've been pretty gracious.
Well, I'm looking forward to seeing it myself.
Well, thank you.
Okay, so let's jump into this webinar here. And I want to start off with your 5 criteria here on how you analyze all the business plans that you are constantly evaluating in terms of workability. So why don't we just go through these points?
Yeah, and I don't think there's any rocket science on this thing. These 5 criteria really are not too different than what you would hear at a venture capital firm, and especially a venture capital firm, because they in particular are looking for things that are transformative. They really do not want incremental changes and technologies that really don't have an opportunity to represent a home run for them. But I look at this the same way, not so much from the standpoint of just greed. In other words, yes, I want big deals. I want to be representing big deals that make a huge impact on the world. But insofar as what we're talking about is clean tech, this is something that has huge humanitarian impact. And insofar as I only have so many cycles in the course of a day, I like to focus my attention where it does the most good. And certainly I don't want deals that have a lot of technical risk. I get things all the time that are, well, some of them are theoretically impossible. Some of them are, not only is it a technical risk, they're a joke technologically. Most of them aren't that, but some of these things I can see are having trouble getting out of the laboratory, and that speaks to the next one as well. In other words, not only does this thing need to work in the laboratory, but it needs to have, it can have issues that won't scale as this thing grows. It needs to have a barrier to entry, whether that's IP protection or something that protects the position of that company in the marketplace. And it needs to have a proven team. I need to be able to believe, I'm trying to make myself believe that these people are smarter than the next guy, and I need to have a reason to believe that. So those are the 5 criteria generally.
And I guess you could fundamentally say that this would kind of, it would preclude the option of just a pure idea. These things are, by having these 5 criteria in place, you move beyond just the idea phase.
Yeah, well, I need a good idea. It does need to have a good idea. But as Ray Lane, the managing partner of Kleiner Perkins, whom I interviewed in this book coming out in January, he says, ideas are the easy part. Ideas are cheap. And is that literally true? I don't know. But he's certainly making a good point. It needs to be a good idea, but a good idea alone isn't going to get the job done.
Good. All right, well, let's start looking at some of the ones that you've cultivated here. So electric vehicles first up, and I know electric vehicles is pretty dear to your heart. Do you have it first because you feel that this is the best opportunity, or just is it purely arbitrary here?
It's arbitrary, but you're right. Electric transportation is dear to my heart. In my estimation, it's a good idea for a great number of reasons, including the fact that it represents energy storage. In other words, the more EVs we have on the road, the more they're charging at night, the more we have a home for off-peak wind and so forth and so on. So it helps integrate renewables onto the grid, the more we can put electric vehicles on the road. And these are 2 of the ones that I happen to like. This first one is a guy who's become a personal friend. I've visited his factory in North Carolina. This is a really clever design on a light-duty electric pickup truck that will be manufactured. I mean, he's building them with just a small staff of people who are hand assembling them, and he can't sell them now for under $25,000, but he really will be able to do this. This is a guy who's come from the automotive industry, and he and his partners have a huge, impressive background in building and in launching cars for Ford and Chrysler and General Motors. I can't remember the entirety of the background, but it's significant. What we will do on this is help get them the money they need to go into manufacturing so that they can scale this. They've got orders. They've got, I think, 4,800 pre-orders of this thing, including the GSA, so the General Services Administration in the United States. You may know is it's like the kind of the purchasing agent for the federal government. So, you know, they've been all over the place with this. Not only that, but they've also been to the Pentagon, who wants to buy these things. You may be aware that the U.S. military is all about electric transportation simply because it saves lives. In other words, they have cisterns of gasoline in Afghanistan that they have to guard. And every time they lose lots of lives associated with the supply chain of oil, and they're tired of it. So they're a big driver of electric transportation, and they love this truck. The other one I want to talk about here is as actually pictured there at the bottom. It's an e-bike, but it's enclosed. So this thing weighs 80 pounds, George. It's not heavy, but it'll do, depending on the way it's finally configured. It's not in manufacturing yet either, but they've got CAD drawings all over the place, and they've got hundreds of dealers who have pre-ordered this. So they've been extremely active in terms of getting people excited about this technology. And I think we're right around the corner in terms of getting them the funding they need to proceed, but who knows? I mean, I never feel, confident until the check cashes, I guess you could say. But I think this is a really cool design. The fact that it's enclosed, I mean, yes, we want commuter transportation, and yes, we like to bicycle and so forth and so on, but we don't like to get dirty. And we don't like to get sweaty. So this thing you can pedal, but you don't have to, and it'll have plenty of range.
Well, Craig, do you have some concept of what the range would be if you did not pedal?
Well, it depends on how it's finally configured. In other words, they haven't actually decided on the battery pack simply because they're not in manufacturing yet. But I would think, I've spoken with these people. I speak with them several times a week. And I think they're probably thinking of 30, 40 miles. In other words, it's a kind of, I don't think you would want to be in a little thing like that much longer than that anyway. And it's for urban commuter transportation. There'd be no reason. I mean, you could give it a bigger battery pack, but there'd be really no reason. It'd just increase the expense and it'd increase the weight. So it's kind of, part of the deal on this is the calculus of, exactly what are you trying to achieve and not overkilling everything. So you want to do whatever you can to keep the weight down and the cost down.
Good.
All righty. So here's the next one.
Wind. Oh, this one's been around a little while.
Yeah, well, wind generally has been around for a little while for sure, and we've made a good, we have 45 gigawatts of wind in the United States. This is coming along nicely. The problem, and the reason I like this and the reason I wanted to talk about it, is simply that this will implement compressed air energy storage. CAES, as it's referred to, and which I think is kind of neat. This is a challenge, as I think everybody knows. There are only 2 implementations of compressed air energy storage on the planet. Having said that, it's one of 4 or 5 different technologies that has the potential to really move the needle here. And as I referred to just a second ago about electric transportation, which of course stores energy in the form of batteries. Batteries are expensive. We pay, $500 a kilowatt hour right now for lithium ion. That cost is coming down, but it's not coming down fast enough. So if we're going to implement a lot of renewable energy on the grid, we need an energy storage solution. Right now, pumped hydro accounts for at least 99% of all of this, but compressed air has the potential, and this is a top flight team. These are people who've been around wind and energy storage for a long time, and I hear them speak. I run into them at conferences, and I'm extremely impressed by them.
Cool. And then the concept of doing something underground or putting pressure underground makes me think of fracking just because it's been in the news. But this has nothing to do with that. There's no similar technologies or no similar risks here. Is that correct?
Right. Yeah. This uses generally naturally occurring underground caverns, most of which used to house natural gas. So in other words, you deplete the natural gas and you use that cavern. The tricky part about this thing, and I'm not an expert in this thing, but what I understand from some of the people I hang out with is that the thermodynamics of compressed air are very tricky. And each cavern has a unique kind of characteristic with respect to the way you need to charge and discharge. And if you don't do that, you take a huge hit in terms of the thermodynamics and thus the efficiency. In other words, you lose a lot of the energy, therefore a lot of the reason that you wanted to do the thing in the first place. So you have to choose the caverns very carefully.
Okay. All right, should we talk about biomass?
We shall indeed. What we have here, of the 19 or so, and by the way, this is not a presentation of every deal that I like. Simply because I had to compress this into a short period of time, I've chosen some of these, but it is representative, I think, of the overall range of technologies. And you'll see that there are several that are associated with biomass. One of my favorites, actually I've got two of these, has to do with a variant of pyrolysis, which is an ancient technology. It comes from the Greek pyro, meaning fire, and the rest of it has to do with separate. So in other words, it uses a high temperature, but in the absence of oxygen, to essentially melt the tires, thus reforming them into biofuels. In this case, high octane gasoline and diesel, and carbon black, which is the char that you get from this process, which is also valuable. So you can imagine, there are 300 million tires that are thrown into landfills or burned up or chopped up and put into playgrounds or roads or what have you every year. There's one for every man, woman, and child in the United States. That's a remarkable fact. But they're very high in energy. So we're sitting on a gold mine here, and so this is about the use of pyrolysis to make valuable stuff.
And it's not likely we're going to be going away from tires pretty soon.
No, that's true. I mean, so who knows what transportation is going to look like, at some point. But we can presume that we're going to be using rubber tires for quite a while. And I did want to mention this thing about the deals that I like. So these are representations of these things that we have on the website. I think they're 19 as we speak, but that changes every couple of weeks as well. But if you go to 2greenenergy.com and look for investors, I think it's under investment and then investors, you'll see all of them, of which these are representations. Okay, so this next one is, did you ever heard of Babasu, George?
To me it sounds like a nice dessert, but I don't like the pictures here as far as edibleness.
You're right. Well, I actually didn't. I thought about getting a picture of Babasu. It's actually it's a palm. It's kind of like a coconut, but it's very energy rich. And this is a plan on the part of some Portuguese people to grow and pelletize Babasu in northeastern Brazil. So, as you're probably aware, Brazil is a real forward-thinking part of the world with respect to biomass. They've declared that they don't want gasoline in their country. And they have almost completely changed over to biofuels. They grow a lot of sugarcane there, and they process it into bioethanol. So there you have it. So this would pelletize. So pelletization, as I'm sure you're aware, is one of 4 types of the way we process biomass. So, and this is the kind of, I suppose you could say, this is the least intensive way of doing this. So in other words, you simply process this such that it can be easily handled. Actually, pyrolysis is another form of what we do with biomass. There's also torrefaction, that is a kind of gentle pyrolysis that changes physically and chemically the biomass, preparing it for to have the energy extracted in some way. And there's also gasification. I think that we have a thing coming up on that.
Now, Craig, for these pellets, the manufacture of these is in Brazil, as you've got noted here, but would they be sold internationally, or is it really just a South American market?
Well, believe it or not, this is something that I'm not bananas about on this, but believe it or not, they have a customer. Their customer is the Netherlands, so they're going to be shipping these things across the Atlantic, which doesn't make an awful lot of sense to me. I think they'd be happier with a customer in South America, but as it turns out, having said that, you do need a customer for this thing. Don't come up with a biomass program that A, doesn't have a guaranteed feedstock, B, doesn't have workable technology vis-a-vis that feedstock, and C, doesn't have a customer. So the fact that it's a continent away is not optimum, but it's better than no customer at all.
And would you say the main barrier to entry on this is just the cost of getting the actual manufacturing put together?
I would say so. It's also the cost of you have those three elements, the feedstock, the technology, and the customer. So they're all somewhat problematic, and the fact that they have, dotted the I's and crossed the T's on all three of them is critical. So they have plans. They know exactly where they're going to do this, what variety of babasu they're planting, how they're going to keep it irrigated and pruned and harvested and so forth. So they've really, the business plan on this thing is, half an inch thick.
Good. So should we look at the demolition waste as
Sure.
fuel?
Here are a couple of other ideas with respect to biomass. One of them, there's a part of the world, I'm not at liberty to tell you too much about this, but there's a part of the world that produces 14 million tons a year exactly, of construction and demolition waste. And it all goes through a central point and winds up in landfills hundreds of miles away. It's a disaster. And moreover, not only are these people paying $75 a ton as a tipping fee, but this is an ecologic disaster insofar as that it has to be collected and then shipped. So this will result in, and almost 30% of it is wood. So in other words, you're sitting on an energy source that is very valuable. So this would essentially redirect those 14 million tons a year in a profitable way. The next one on this thing, one of the largest cities on Earth develops 15 tons a day of municipal solid waste, of which these people have a contract under which they'll be taking 3,000 tons a day and turning that into, among other things, 130 megawatts of electricity. That's a huge amount. This is a country that doesn't make its own electricity and spends $500 billion a year buying electricity from its neighbor. So they obviously don't like this, and they have, at the highest level of government, they've contracted to this MSW plant. This is going to be a really good deal.
Good. And by the way, Craig, I should mention that if any of the listeners have any specific questions about these technologies or these particular deals, just type in your question on the left of your screen and click Ask Question. All right, you ready to go? Oh, you're solar thermal. You're definitely ready to go. Okay, here we go.
Well, yeah, as you know from having spoken with me all these years, George, I really love solar thermal. I'm not alone in this, but there are people who are detractors from this, who don't think that solar thermal has the potential to really change the game in terms of the energy picture in the United States and around the world. But there are a bunch of people who agree with me. Having said that, one of the big costs, one of the issues with solar thermal, aka concentrated solar power, CSP, is, as suggested in this picture, you've got various ways of concentrating the sun's rays on a certain point or a certain line. In the case of parabolic troughs, it's a line. Here you can see that it's a point. The issue, as suggested in this picture, is tracking the sun. So as the sun moves across the sky, you need to move these mirrors in real time. So that suggests all manner of electronics and motors and actuators and so forth. That's the expensive part of this. Most of the rest of this stuff is steel and aluminum and glass and sand and concrete footings and so forth. It's extremely abundant, inexpensive materials. Having said that, so again, the real cost on this thing is moving those mirrors, and this is a series of people working as a team in the Bay Area, PhDs, brilliant people. I've met them. I'm very impressed with them. That have a breakthrough with respect to this thing. So I couldn't tell you what it is if I wanted to, exactly how this works, but I know that they've greatly reduced the cost of moving those mirrors. So that's what makes this attractive. They have 3 small plants that they propose to do in the western United States in 3 different locations. They have power purchase agreements in place that are very attractive, as you can imagine, but they're small. I mean, these are 1 megawatt, 1.5 megawatts. And they're simply pilots. So in other words, this thing is working in the laboratory. Now it's time to build this and to show the world that it can work. So having said that, the IRR, the internal rate of return on even this thing, this is going to be, let me think, I think they need $15 million to buy all these, to install all these. So which obviously $15 million times if you're talking about just a couple megawatts, that's a lot. Having said that, this is, insofar as this is a pilot plant, this is really going to show the world how easily this can be done.
Good, and this could, of course, be implemented elsewhere in the world using this technology as well.
Absolutely. Well, what I believe is going to happen on this thing is that as soon as this is proven, people around the world are really going to want to do this. So the promise on this thing, by the way, is simply that not that you would do this, but if you wanted to, you could build a solar thermal farm in the shape of a big square, 92 miles on a side, and if you were to do that and put that in the middle of the southwestern desert in the United States as an example, you'd have more than enough power for the entire continent of North America. Now, you have issues if you want to do that. You have issues with respect to use of land. The desert has limited uses, but it does have uses, and it does have ecologic impact to cover 92, 10,000 square miles with anything. So you're not talking about an issue that's completely free. You're certainly talking about power transmission issues. So you're going to use high voltage direct current to ship that power to the population centers, but that comes at a cost as well. We do need to build out our grid anyway, but that's going to be an expensive proposition. You also have legal issues with respect to eminent domain. So we have used eminent domain to build railway systems, and so we can ship train cars, we can ship automobiles. We have the highway system. We ship all kinds of stuff with natural gas around the country. It seems to me that we can figure out a way to ship a couple of terawatts of electricity. But right now, this is a problem. This is a legal issue. As a matter of fact, there was a recent Supreme Court decision that would make this even tougher, that allows local municipalities to get into the game with respect to eminent domain. So we're going backwards and not forwards. I still think, however, that solar thermal has the opportunity to work.
Now, Craig, a question here. So when you're talking about the potential of putting this in a large plot of land to energize the continent, wouldn't it be more cost effective though to have smaller implementations in any place that gets a lot of sun?
Well, that's what will ultimately happen for sure. and as some people have been writing in talking about the cost needs to come down and it doesn't work it only works in dry climates and so forth. There are limitations, and you're exactly right. There are limitations to what you can do with this thing, and you're right. You would want it distributed for a great number of reasons. One is security. In other words, you don't want to have hundreds of gigawatts all in one place for security reasons.
Yeah. All right, well, shall we look at synthetic fuels?
Shall indeed. Let me see which one this is. Okay, now this gets back to essentially energy storage. So, which is a subject, as I've mentioned, that is near and dear to my heart, because we're almost exactly 2% in terms of renewables. We have maybe 8% hydroelectricity, but in terms of wind and solar and run-of-river hydro and geothermal and biomass, we're still under 2% in the United States, and that's pathetic. That needs to change. This is unsustainable. So, and we will get there. But the path to getting there is a very interesting one, it seems to me. And most of the people who have studied this have convinced me that it needs to come in concert with storage. So we have huge amounts of off-peak wind. We have curtailment. You have developers of wind farms who can't sell their product. So in other words, they curtail. They have turbines that aren't working in the night, which is when we need the energy the least, but it's when the wind is blowing the hardest. So we have an issue with respect to storage, whether it's solar or wind or what have you. Most of these things are intermittent, not all, but solar and wind certainly. So the issue is, what do you do with this? Well, there are various approaches, and we talked about compressed air, we talked about pumped hydro, which is most of, when we do energy storage in the United States now, almost all of it is pumped hydro. The problem with that, not only is that pumped hydro is only applicable in certain places. In other words, if you don't have a natural change of elevation, it becomes horrifically expensive to implement. But it's also obviously stationary. So here is an approach. People have been trying to do this for several decades. But the reason it's so attractive is simply because it's portable. So you want liquid fuels. It is going to be, yes, we're going to electrify our transportation system, but we got 230 million cars and trucks on the road. We've got a long way to go until we have replaced the internal combustion engines in the United States with electric transportation. And certainly in terms of Class 8 trucks, gross vehicle weight of anything over 35,000 pounds, the definition of a Class 8 truck, it's going to be a very long time, pardon me, before we implement electric transportation with large trucks and certainly aircraft. So synthetic fuels are extremely attractive. People have been trying to do this since the 70s without any real success. I believe one of our clients at 2 Green Energy, I believe, has a legitimate breakthrough in this thing and proposes to use large amounts of off-peak wind together with electrolyzed water. So, you need a hydrocarbon, so you need hydrogen. You can get that from electrolyzing water. You need lots of carbon dioxide. The carbon comes from carbon dioxide, which is good, thus making this whole thing carbon neutral, because you're using the carbon from the carbon dioxide and then, of course, releasing it in combustion. So that comes at places like concrete factories and power plants. So this is a multi-step process pardon, that has to do with creating synthetic fuels through those processes. And the rest of it, it gets into some pretty gnarly chemistry, but this guy's been at this a long time, extremely bright guy, and I'm a complete believer in what he's proposing to do there.
Good. And there's more energy storage ideas that are percolating.
Yes. So this is what I believe to be a breakthrough with respect to battery chemistry. So this is a picture there of pumped hydro, which, as I say, represents the vast majority of what we do. Having said that, these people have been 5,000 or 6,000 cycles through testing of a zinc air battery chemistry that they claim. I met them at the Energy Storage Show last summer, I guess it was. in 2013, you're going to be selling this at $165 a kilowatt hour. So that's, a third of what we're paying for lithium ion. And it's got various advantages over lithium ion as well, in terms of power density and, but I mean, the cost is the huge thing. In other words, the reason you can't do the reason we're having trouble with electric vehicles and creating a value proposition that's correct for the customer is simply because of the expense of the battery pack. So here you have a huge change with respect to that. You also make this available for utility scale grid storage. There's certain utilities in the United States. I have a friend at Southern California Edison, and I've heard her presentation on this, and they're implementing, as we speak, they're implementing 8 megawatt hours of lithium ion up in the Tehachapi Mountains. 8 megawatt hours, that is a flea on the dog. And when I asked her about that, she goes, "Yeah, I know. But we're doing this just so we can say we did, and this is a test, so forth and so on." But until you have something that you can deploy at scale that makes sense in terms of cost effectiveness, you might as well not be messing with it at all. It seems to me. So this does really have the power, it seems to me, to move the needle and really make a change here.
And is there any reason why this may not work at scale?
Well, I don't know, except to say I haven't seen this. I haven't seen their laboratory. The next time I'm back east, they're on the East Coast, I'm going to have a walkthrough, and I really want to see what they're all about. Having said that, the answer really is no. Zinc is very common, very inexpensive. It uses atmospheric oxygen. So in other words, you don't cart around one of the electrodes, which is kind of cool. It's very attractive from that standpoint, it seems to me.
And when you say it has a huge impact potential on electric vehicles, now you mean that it's not only less expensive, but it actually is more compact, so it can be smaller batteries, or the batteries will last longer?
Yeah, well, you get into what's called power density and energy density. And there are 2 flavors of each. You have volumetric and you have gravimetric. So in other words, you want something, especially for electric vehicles. Let's just take an example of this thing. So you have something, you want to put, say, the Nissan Leaf has 24, I think it is, kilowatt hours on board. So that needs to be stored in a place, in a space. You don't want something the size of a refrigerator in your car. If you've opened the hood of your car recently, you've noticed there's not a heck of a lot of extra space in there, and that's by design. So they do whatever they can to minimize the use of space. Obviously, and especially with respect to electric vehicles, you don't want a lot of weight. So you have the gravimetric energy density issue there too. But you also have power density. So in other words, the same, which of course is how much energy it's using in a given unit of time. So in other words, it's fine that you've got this really inexpensive and small place to keep so much energy, but it's not cool if you have a power density issue. In other words, you only get to it so quickly. And there is an issue that they're trying to resolve with respect to power density. It's not very good. Now that is a huge issue for electric transportation. It's not as big an issue, obviously, for grids, energy storage. But as they've convinced me, there are workarounds for this power density issue, and they'd much rather have a power density issue than a cost or an energy density issue. So not only are they trying to handle this technologically, but you can, if you really want to do this in electric transportation, you don't have to you can put lead acid in there for a little bit of lead acid that has no power density issues, or you could use capacitors or whatever. So they'll solve this problem.
Good. All right, do you want to talk about processing coal ash for the purpose of creating building products?
Yes. So these were some of the first people I met when I started to, throw my hat in the ring and tell the world that I was willing to review any business plan that people had for free. All of a sudden, I got this thing having to do with the extrusion of a kind of a resin that is used in conjunction with coal ash to make business products. So what you have is this proprietary way of taking what is we've come to understand, not a benign substance. So 49% of our electricity in the United States comes from burning coal, and that coal ash, we've come to realize in the last couple of years, has a toxic effect in our environment. So we're trying to process that in a way that turns lemons into lemonade, essentially. And I know there are different approaches on this thing, but these people have what I believe to be the best. And you can, as I suggest here, you can extrude fence boards or just other types of wood products, things that are substitutes for wood. They can't really do that cost effectively. You can chop up a tree and get a 2x4 at about half the price of this. Having said that, this is fantastic for shingles. That has fantastic color, characteristics, fantastic survivability. So that's really the way to go with this. And I'm serious about this thing about lemons to lemonade. So in other words, if you're Duke Energy or somebody who's got, there are 800 coal plants in the United States, and places like Duke Energy have a lot of them, and this is causing not only an environmental problem, but a legal/risk problem. If you're, the chairman of the board, you don't want that level of risk associated with your business processes. So I have a feeling that they're ultimately going to be very successful in selling this and implementing this with the coal plants in the United States as we become more intolerant of the idea of just making piles of this or burying it or doing whatever they're currently doing with it. The issue is, it's kind of interesting though. I had a client years ago who has this technology for mitigating, you may have run across this idea that cell phones can cause brain cancer.
Yep.
So, this is kind of unproven, but every time Motorola or Verizon does a test on this thing, it comes up negative, and every time anybody else does one, it turns up positive. So, you have to think there's been some, hanky-panky played with the numbers on this.
Yeah.
But the problem, if you go to sell Motorola or whoever on this thing, the reason they don't want it is because implementing it would be admitting that there's a problem. So part of the problem that I'm having, I believe, with selling this to the Duke Energies of the world is simply that it's the analogous problem. They don't want to admit that there is an issue with coal ash, even though this is becoming more important.
Now, to address the obvious on this stuff is toxic, and it's at least while it's being used there. Does the processing remove that toxicity? Or are we just moving the toxicity from, potentially the air and the local environment to, rooftops and property parameters or property boundaries?
Well, what it does is essentially encapsulate it. So it's a proprietary resin that, when mixed with coal ash, changes the chemical and physical properties of it. So now all of a sudden, instead of a powder that's leaching into the groundwater, now it's a solid. It's a roof shingle that's not eroding, it's not leaching.
Okay. Good. And I should also mention that we've only got a couple of slides left here. So for anyone who has questions that they want to ask, be sure you get to them so that we can pick them up here in just a couple minutes.
Mm-hmm.
All right. So do you want to go to renewable energy decision support?
Yes, but before I do, let me just take a couple of these points insofar as they're relevant to what we're talking about here. Paul mentions that there's more RF in a baby monitor than in a cell phone. I haven't studied this recently. So this is a wide range. First of all, this is a wide range of electromagnetic radiation. So I'm not sure it's associated strictly with RF. And this was very interesting. Paul, you're obviously interested in this, and I'll just tell you briefly what this thing does. It just emits noise, electromagnetic noise. And the basic concept on this thing is that what is damaging and what has been proven to change our DNA, not our DNA, but the DNA of rats and various other things that they've studied with respect to this, is the repeatability. In other words, the fact that the signal that you're hearing over the phone or however you're hearing this is regular. In other words, the wave form is regular. And that's what eventually affects and causes mutations in DNA. So those mutations have not been linked to cancer, but most people say, I don't want mutations anyway. I don't, even if they're not, even if I can't be proven to show that they cause cancer, it's just not good that we're associating ourselves with electronics all around us that's causing mutations in our DNA. I think. So I'm perfectly sympathetic with that viewpoint. So what this does is it simply emits noise. On top of the regular signal, you have a noise signal, and noise plus regularity equals noise. It's extremely simple. So very good. So we'll take it from there.
All right.
We're
Do you want to
talking
get into
about, yes.
Okay.
So very good. So this actually was the subject of a webinar that we did not too long ago, where this team of people have developed software that enables its user to say, okay, I will, instead of doing my wash or whatever it is right now, if I wait an hour, I'm going to be able to get a much higher concentration of renewable energy. For whatever reason, the availability of the weather forecast is showing that it's going to be sunnier or whatever. I mean, that's an example. But what happens on this thing is that, yes, you can do this at the consumer level, but you can also do it at the business level. So, for instance, huge computer campuses don't heat their buildings. I just learned this the other day. So the huge, and I can't name names, but you all know who the big ones are. They don't heat, even in the winter, they don't heat their buildings because there's so much heat from human bodies and from computers. So, but what they do is they chill. You have in the heat of the summer, you have too much heat, and you have to air condition it, and they use that with water chillers. Now, how do they run those? Well, what they do, far-sighted people have decided that the thermal inertia of cold water is considerable. If you're going to chill your water for the day, it doesn't really matter if you do it at 4 o'clock in the morning or 6 o'clock in the morning, as long as it gets done before the place starts to get hot. So here are people who use this software to say, okay, let me do it. I want to do it at 4 o'clock in the morning because I have because there's wind blowing like nobody's business. So in other words, you use this software to specify when you want to consume electricity, simply because you'll have a higher concentration of renewables and a lower concentration of coal. So if you implement this today, what you're probably doing is forcing somebody else to consume more coal, simply because they're not a statistically significant number of users. But what happens when you get almost everybody doing this? Well, then the utilities get to say, you know what, we've moved the peak. The peak, what used to be 3 o'clock in the afternoon to 6 o'clock in the afternoon now has a completely different characteristic, and we can count on this. It's happening every single day. So it's kind of like the analogy I did is, people want to do all this energy storage stuff to adjust the load, the availability to the peak load. So this says we don't have to do that. We can move the peak load. So moving the mountain to Muhammad, I guess you could say.
I imagine it would take a little time, but I got the idea.
Yes. Yeah, exactly. So it is something that needs to be implemented over a period of time.
Okay. You want to go on to hydrokinetics?
Yes, I do, but I want to take a question here.
Okay.
This says, please comment on the energy in versus energy produced in the biomass methods. I think I understand this. So, pardon me. So the issue is, so obviously the energy stored in biomass is stored in the high energy bonds, the hydrocarbons, and it's released in various ways. So it turns out for 1.9 million years we've been burning stuff. So I just learned this the other day. Java Man, there's fossil evidence that Java Man 1.9 million years ago was cooking as food, so which I find remarkable. It was much more close to present day that mankind learned to control fire, but we've had fire around for a long time. So combustion is one element of this thing, but with these other types of things that I was talking about, pyrolysis and thermal anaerobic gasification, and various other flavors of both of these things, we are able to extract that energy in more ecologically benign ways. Now the issue is, I think what this question is getting at is how much is there? In other words, is there enough to really move the needle? And the answer is kind of a mixed bag. So in other words, the Earth receives 6,000 times more energy from the sun every day than all 7 billion of us consume. So there's obviously something to like about solar energy and the other kind of variants of energy that we get based on the fact that the sun is shining, for example, wind, for example, waves, etc. Having said that, these other things play an important role in contributing to an ecologically sensible future. Biomass being an example, and hydrokinetics being another. So, in other words, if you take if you wanted to, you could say, well, what's the issue with hydrokinetics? Run of river, if you multiply the weight of all the water in the rivers in the United States times the altitude from which they're falling, in other words, that's the total potential energy of all that water, you're still in the gigabytes. You're not even in the terabytes, and we use 5.4 terabytes as we speak. So is this an important technology? Well, I'm convinced that it is. So all of these things play important contributions. We've got enormous amounts of things like waste wood that can be, we talked about tires. We have millions, tens of millions of railroad ties. So think of all the wood that is kind of taken out of circulation every year. Now, what do you have when you get creosote-soaked railroad ties? So you have, which if you burn them, you have an enormous amount of carcinogens you're dumping into the atmosphere. So you don't want to do that. But here comes along thermal anaerobic gasification, which can take the gnarliest waste wood, that being an example, other treated lumber from construction and demolition waste, and extract the energy without producing carcinogenic slag. So there you go. So we wanted to talk about hydrokinetics. So I do have a few of these things that extract the energy from moving water. Up until recently, I had nothing that had to do with high head conditions. So in other words, waterfalls or steep rapids. I had a call from a guy in northwestern Spain not too long ago with a really fantastic idea. I'm under NDA, I can't tell you too much about it, but just imagine, look at that waterfall and say, okay, how can I extract that energy inexpensively and aesthetically? So in other words, I don't want some horrible device. I don't want something, I can't dam up the river, I can't make it impossible for fish to swim upstream, though that looks like a challenge for any fish. But we're getting away from hydroelectric dams generally, but we certainly want the energy in moving water. So how are you going to do that? Well, this guy has a unique approach and capability in that space, which is important not because there are terawatts of hydrokinetic energy available, but because there are certain parts of the world where there really is no better solution. So you have extremely remote areas of rural, wherever, where this is really the only potential way of electrification, and this is a really cool idea.
Nice. All right, Craig, we're running out of time here. And if you want to field a couple more questions as you can, that would be fine. I also wanted to mention that if anyone is interested in seeing the full list of these, you can certainly go to twogreenenergy.com, and you can get there a couple of ways. One simple way is at the very bottom of every page. It says Deal Summaries with a picture of a gold bar, and you just click on that, and that'll just take you. You want to scroll down, and you'll see the list of current investment opportunities that Craig has culled from all the business plans that he's reviewed, and this does change periodically, as he mentioned.
Exactly right. So the only other thing that I want to talk about here is just a question. Somebody asked if I know about the solar thermal storage flywheel. I can't imagine what that is, but I have to imagine. Certainly, you can. We're talking about storing energy, and flywheels. In other words, storing it as mechanical energy is a popular way of solving this problem. I've never heard about it in solar thermal. The beauty of solar thermal, it seems to me, is that the energy is by definition heat, and you can store heat energy in molten salt, as an example, far more cost effectively than you can in batteries. So yes, you could convert the heat energy to mechanical energy, but I can't imagine why you would want to do that. I'll Google that and see what I can find. But anyway, thank you, and thank you, George. Good job on this. So anything else you want to say in closing?
Yeah, if anyone has some questions that they would rather be discussed on email or by private phone, just go to the left of your screen and enter your question and your email or phone number, whatever is pertinent. And that's all.
Yeah, but actually, a better idea, since this is going to be closed soon, a better idea is just to hit the contact bar on the website, it seems to me, the contact button.
Yeah, you're right. Yeah, that would be that they can do at any time at all.
Yes, and that and I will get right back to anybody with a question or a comment. Thanks everybody for being here. George, good job, my friend. Nice to talk to you again.
All right, and then we'll have the next webinar posted pretty soon as well.
Exactly right.
All right.
Have a good day.
Take care.